Alright, so this is Unit 1, Day 2, still limits, but we're going to have to do some algebra today. Yesterday was almost entirely graphical, like looking at the picture, very conceptual. Once you get the idea, not really that hard to just look at the picture, and as long as you know what you're looking at, not a big deal. Today, some algebra we're going to throw in. The first several properties here you actually already used in yesterday's assignment. The sum of the limit of the sum is the sum of the limit. Like, it works like you think it should work. So like, this is not a big deal. You already used these properties. I guess the one I might call your attention to is that if there's a constant multiplier in there, he can slide out front. Which makes sense. We can do that with a lot of multiplication things. You can slide them out. So the first ones, those all work like you think they should work. There's not really much to say about those. The big part of today is these methods that we'll look at. And I kind of don't like how this set of notes organizes this, so I'm going to give a different sort of outline. It's going to be the same topics, but a different outline for the methods. We'll do it in this blank space, and then we'll get into the details in a minute. Method 1, substitution. Always try it first. Always try substitution first. Sometimes it works. If you get a nice answer, then you're done. Now, usually we rig the problem to not give you a nice answer because we want to force you into the algebra methods. But it needs to be said that you always try substitution first. And if you get something weird, meaning 0 over 0 or infinity over infinity, then those don't work, right? Because normally we say if 0 is in the top, it's equal to 0. If 0 is in the bottom, you can't do that. But what if it's both? It's like, if it doesn't work, then we'll go to our algebra techniques. So Roman numeral 2 is going to be 3 different algebra techniques. All right, you can factor and cancel. And again, we'll get into the details on each of these in a minute. I'm trying to big picture lay out the process here. You can factor and cancel. You can simplify a fraction. And because you're never going to do all of these. You're going to multiply by a conjugate. Okay, so the good news is you've done all 3 of those things before in your algebra life. Now we're just sort of grouping them as a way to solve limit problems. Now, if you look at the notes on this page and the next, it just lists the 4 different ways to do the 4 different methods, but it lists them like, just pick one of the 4. But it's not really that way. You always try substitution first, and if that doesn't work, then you go to one of the other methods. All right, now let's dive into the details on this outline here. So substitution. Let's get that to focus for us. Again, I'm calling that Roman numeral 1. Always try it first. You don't know if you need one of the other methods unless this one doesn't work. So let's just plug in x equals 1. Let's see, 4 minus 8 is negative 4. 2 minus 4 is negative 2. So that answer is 2. That seems like a perfectly reasonable answer. So that's our answer. Again, the trick is try substitution first. What will mess people up is they'll try some fancy method on a problem that should have just been substitution. And I get it, most of them require the fancy methods because substitution is really easy, so we don't give you very many of those. But when we give you those, we hope you get them easily rather than trying something crazy when all you had to do was substitute. Part B here, or number B. Plug in 2. 4 plus 2 is 6. 6 plus 10 is 16. 3/8. Got a perfectly reasonable answer. Same thing with C. Plug it in. That's an easy one with the zeros. You end up with negative 5/3. So sometimes substitution gets you a nice answer, and then you're good. Letter D. Cosine of 0. What's the cosine of 0? Pre-cal experts. 1. Good job. Must have had a great pre-cal teacher. Cosine of 0 is 1. 3 times 0. 3 times 0 is 0. So something is going on here. I can't divide by 0. I don't like this example. It's in the wrong spot. But I'm dividing by something that's really, really close to 0. Does that make sense? Because this is the limit as x approaches 0. So 1 divided by something close to 0, you know what that is? 1 divided by a really, really small number? Infinity. If I tried to fit 0.00001, how many times would that go into 1? Well, infinite. But it could be coming from the negative side, so it doesn't work. It's either infinity or negative infinity. So that doesn't work. Let's try another one with 0. Because the sine of 0 is 0. And 0 divided by 7 is just 0. So that's fine. 0 is an okay answer. F. Look at this. E to the infinity over natural log of 2. What happens if we did e to the infinity? What kind of number is that? Yeah, big. Really big. Infinity even. And I don't know what natural log of 2 is, but it's just some kind of number. So infinity divided by something is infinity. It's kind of weird working with infinity. Take infinite and divide it by 7 or 12 or even 5 million, it's still infinite. All right, last one. 1,000 over 2 times infinity minus 4. Well, 2 times infinity is still really big. Subtracting 4 doesn't really do anything for us. What's 1,000 divided by a really, really big number? This is if I had $1,000 in my pocket, I don't try to rob me, and I divided among everybody on Earth, like approximately how much money would each person get? Almost 0. And if there were more people on Earth than there are, it would be even closer to 0. So it doesn't really matter what the top is. If you're dividing by infinite, you're headed to 0, right? Even if it's $1 million divided by an infinite number of people, everybody's getting nothing. So those are all sort of acceptable answers. Let's talk about some of the weird ones, though, a little bit in more detail here. When you plug in your x value, if you get a non-zero real number divided by 0, so if you're dividing by 0, that gives you a big number. Take a real non-zero real number, so some regular number divided by infinity, what's that going to be? that's going to be 0, right? Whether it's 12 or 7 million or -4, like if you're dividing by infinity, you're headed to 0. Zero over a non-zero real number, so 3 or 5 or -12, that's 0. Properties of 0 infinity here. Infinity divided by a non-zero real number. A non-zero real number is like 2 or 1/2 or -47. That's still infinity. Okay, but those are still sort of under the normal caseload of things. If, don't turn the page yet, if you get 0 over 0 or infinity over infinity, those don't follow the same rules. If you get 0 over 0, it's like, well, which rule matters? Because 0 in the top means 0, but 0 in the bottom means infinity, so which one is it? Same thing. If infinity's in the top, that usually means infinity. If infinity's in the bottom, that usually means 0. Like, which one is it? Well, that's when we have to go to our algebra techniques. The more interesting, and of course when a math teacher uses the term interesting, it probably means harder. The harder limits are when we get to the indeterminate form. That's what 0 over 0, infinity over infinity. The fancy name is indeterminate form. Because it's indeterminate. We don't know enough to get an answer yet. There's multiple indeterminate forms. Really the only ones we're worried about are 0 over 0 or infinity over infinity. You can look at the others and think how they're indeterminate as well. Like infinity to the 0 power. Like, well, anything with a 0 is 1, but if it starts out at infinity, is that really 1? It's like, meh. Same thing with 1 to the infinity. 1 to the infinity should be 1 if that's exactly 1, but if we're dealing with limits and it's like really close to 1, and you raise it to itself a million zillion times, then it might not be 1 anymore. So there's some weird things going on. The only weird things we're worried about are these weird things. Okay, so this is Roman numeral 2. We'll say other techniques if you get 0 over 0 or infinity over infinity. So I'm going to call this, just redoing the notes here, this is not Roman numeral, that's letter A. Factor and reduce is one of the options. And I don't really want to do all of these, so let's see. We'll do a couple. But you still always try substitution first, so always substitute first. Because you don't know if you're supposed to use these unless you try substitution. Now, it's a little bit weird because this section says factor and reduce, so we know we're going to have to factor and reduce. But on the test, the AP test, in the homework, it's not going to be like grouped by section. It's just going to say find the limit, and your first job is going to be substitute and see what you get. So that would be 4 plus 8 minus 12. If I plug in -2. And then in the bottom, square of -2 is 4. 4 minus 4. Alright, sure enough, I get 0 over 0. Which I knew was going to happen because it's in this section, but we're supposed to always do that first in case we get a nice answer. Okay, so let's back up and factor this thing. Let's see, x and x. Two things that multiply to 12 and add to 4. So 1 and 12, no. 3 and 4, no. 2 and 6. And I would need the 6 to be negative and the 2 to be positive. At this point, we're just assuming you know how to factor. Hopefully that's not too big of an assumption. X squared minus 4, that's the easy one. X plus 2, x minus 2. And hopefully a little light bulb goes off in your head, because what can we do next? Cancel the x plus 2's. And so after you do the factor and reduce, then you substitute again. In fact, that's going to be true of all these methods. You're going to substitute, it's not going to work. You're going to do an algebra method, an algebra trick, something fun will happen, and then you substitute again. So let's try again with plugging in negative 2. So now we've got negative 8 over negative 4, and now I've got a nice, normal, regular type answer. Okay, we don't need to do all these because they all work kind of the same. But there is some factoring stuff on there. Why don't you try C? Well, I guess first let's plug in 2 together here. So 2 times 4 is 8, minus 2 minus 6, over 4 minus 4, yep, 0 over 0. So why don't you see if you can remember how to factor the top? Letter D. If I plug in negative 3, I'm not going to show the work. I am going to check it. Negative 27 plus 27 is 0. Negative 3 plus 3 is 0. So yeah, I've got to do something with this one. You could probably guess why I picked to do this one. Do you remember how to factor x cubed plus 27? What's it start with? X plus 3, which there's kind of a big glaring hint in the denominator down there. But what about this second term? What goes in there? Good. Same, opposite always positive for the signs. SOAP. Square the first one, multiply the two together, square the second one. Again, we're counting on the fact that you remember how to factor these things. X plus 3's will cancel. Plug in negative 3, get 9 plus 9 plus 9 is 27. Let's see, E, that's another difference of squares, difference of cubes. On F, how would you factor the denominator of F? How would you factor that? Yeah, take an x out, x squared plus 2, then the x cancels, and you're off and going. So, if you can factor, those are pretty easy. Little side note here, never write that the limit is equal to 0 over 0. You'll notice that I never wrote that anywhere. That the limit, I wrote equals 0 over 0, but I didn't have the limit equaling that. Because the limit is not equal to 0 over 0. If you write that, even if you kind of fix things later, you won't get full credit. So if you write 0 over 0 somewhere on your paper, that's okay. But don't ever, in fact, I probably shouldn't even have it there. Even though that's kind of iffy, because I never said the limit was equal to that. I just said this was equal to 0 over 0. The best way is to not put equal to anything, just have 0 over 0 kind of floating, and that's sort of your note to self that I got to do something else. But don't ever say that the limit is equal to 0 over 0. Because it's not. The limit's 2 or 7 halves or 27. All right, so that's one technique, is the factor technique. Another technique is simplifying a complex fraction. And again, we're going to assume your algebra skills are reasonable, and hopefully we don't need to do all of these examples. Let's substitute first. So if I plug in -5, that would be -1 plus 1 over 5 plus -5. That's 0 over 0. Being careful not to write any equal signs, because the answer is not 0 over 0. The answer is I need to do something to fix that. Oh, if we're sticking with our new labeling system here, this is choice B under the other techniques, simplifying a complex fraction. And then substitute. Okay, fractions and fractions. We don't like those. What could I multiply by to make the fraction go away? X. Let's multiply top and bottom by x. That'll make that denominator go away. It'll add an x to everything else, but that's fine. I really just want that bottom x to go away. So the top becomes 5 plus x. The bottom, you know what? I'm peeking ahead here. I don't think I want to multiply in the bottom. I think I just want to leave it 5 plus x times x. Oh, that's convenient. The 5 plus x's will go away. There's still a 1 in the top, right? Don't forget that. So I substitute again, and I get -1/5. Again, I don't want to do all of these. What would I multiply by on part B, or on example B? Good, 2 and x. So let's pass on that one in the interest of time and do one that's a little harder here. How about C? What should I multiply by that would make all the denominators go away? X plus 2 and x plus 1. And remember, you got to do that to top and bottom. And my guess is that something is going to cancel, so I probably don't have to multiply out the bottom. I probably want to leave that factored and hope that one of those things goes away. But I will need to multiply out the top. Let's see, so the x plus 2's will cancel, and that would leave 5 times x plus 1. On the second term, the x plus 1's cancel, so -4 times x plus 2. And then all that stuff in the bottom. Again, I'm not multiplying that out because I'm expecting something to cancel out of that denominator. So I need to clear up the top and hope that something cancels. So 5x plus 5 minus 4x minus 8. I'm not going to keep rewriting that denominator. I'm going to be lazy. Denominator. So the top becomes x minus 3, which is perfect, because now the x minus 3's will cancel, and I need to remember that I'm doing a limit problem. And the whole point is now I can try substitution again. So 1 over 3 plus 2 is 5. 3 plus 1 is 4. So my answer is 1/20th. This is sort of just a giant algebra review day. Can you factor? Can you deal with fractions? Why don't you try, we're doing good on this. You try letter F. So there's the conclusion of that example F. Clearing out fractions, reducing, and you can leave it like that. Then we fast forward to multiply by a conjugate. But what is a conjugate? Do you remember? Or, like, what would we multiply the top and bottom on this one by? The square root of x plus 4. And the idea with conjugates is it makes the middle term go away. So let's see what happens when we multiply the top and bottom by square root of x plus 4. So in the top, we're still just foiling. Square root of x times square root of x would be x. The outside and inside should cancel. That always happens with conjugates. So minus 4 root x plus 4 root x, I don't need to write that. That cancels every time. Minus 16, oh, that's good. Because in the bottom, there's an x minus 16. It always works this way where on the conjugate side of things, you want to multiply that out. On the side that's not a conjugate, don't multiply it out. For one, it would be really ugly. Like, I hope you could multiply that out, but you'd have 4 terms and they'd all be ugly and you don't want to mess with that. So multiply out the conjugate side of the fraction, and then what should happen is that something should reduce.
Does the conjugate always come from the top of the fraction?
That's a great question. Look at example B and tell me what you think the answer to your question is. The question was, does the conjugate always come from the top of the fraction? No, because when we get to B, it looks like we'll need to fix and clean up the bottom. So usually you can tell by looking which side you need to conjugate. All right, the last step is the same, like the first step and the last step is the same on all of these. Substitute. If you get an answer, great. If you get a bad answer, then do one of the algebra tricks, and then the last step is, again, always substitute. So n goes 16. We'll just get carried away with our safe stops here. That's an acceptable stop. There's obviously more you can do to simplify that. That answer is not okay in pre-cal or algebra 2, but in calculus it's fine to leave it like that. And I would argue better to leave it like that. Because, sure, I hope you can get that to 1 over 8, but you don't want to risk making some dumb mistake and end up with 1/4 or 1/6 or something weird. So if it really bugs you, you can simplify it more, but my encouragement to you is take advantage of the safe stop and leave it alone. That way you don't miss 2 points because you did something dumb. All right, example B. What do you think we should multiply the top and bottom by? Square root of x minus 1 plus 2. And we'd really have a mess in the top if we multiplied that out. But we don't want to multiply it out on the top. We're hoping that something cancels. In fact, after you do a bunch of these, you can kind of guess what's going to cancel. If I plug in 5, I get 0 over 0, so I would really like that 5 minus x to go away. So I'm guessing that's what's going to cancel in a minute. But let's see what happens. So leave the non-conjugate side alone because we're hoping something cancels. Do fix the conjugate side because that's the whole point of multiplying by a conjugate, is hoping something will cancel for us. Oof, careful here. Square root of x minus 1 times square root of x minus 1 is x minus 1. And the middle 2 terms would be ugly, but what happens with the O and the I of FOIL when we multiply by conjugates? They always cancel. So you can do kind of a quick look and see, or you can just be like, they're going to cancel, I'm not worried about it. And then negative 2 times positive 2 is minus 4. So 5 minus x, square root of x minus 1 plus 2, all over x minus 5. Good. This is the example I was hoping we would get to. Jace, you with us back there? What happens, or how do 5 minus x and x minus 5 cancel, or can they cancel?
Yes, you just have to add in a negative.
Perfect answer. Add in a negative 1 in the bottom or the top, it doesn't matter. So the easiest way is to just say, yeah, they cancel, but they leave a negative 1 because they're off by a sign. Now, the longer way would be factor out a -1, but most of the time calculus students are like, no. They just cancel to -1. Now we can try our substitution again. Don't forget that -1 out there. I'm feeling extra safe stoppy, so you could leave it like that. That bugs me to see, but I should leave it like that. Square root of 4 is 2, 2 plus 2 is 4, so -4. Either one of those answers is okay. A quick word about the safe stop answer is that it really won't be available on the multiple choice question. So I need to make sure you can get there. If it's a free response question, then safe stop it. But if it's multiple choice, that's not going to be one of your answer choices. You're going to have to simplify. All right, we got time for one more. C and D, you can tell, are pretty similar. Maybe they don't look like conjugates because there are not square roots involved. So let's plug in 0 and see what happens. Cosine of 0 is 1. Sine of 0 is 0. So 0 over 0. And you think about our other methods, there's nothing we could factor to make that work. There's no fractions to clear up. And so our only option left is multiply by a conjugate. Now there's not a square root in there, but there's also only one side with a minus sign in it. So what do you think we should multiply top and bottom by? Cosine of x plus 1. And we'll just see what happens. Same type rules. The conjugate side, multiply it out. The non-conjugate side, leave it alone and hope that something cancels. So cosine squared. Inside terms always cancel with conjugates. That's why we do conjugates. Minus 1 over sine of x, cosine x plus 1. Nothing cancels. But the top equals something. Sine squared plus cosine squared is 1. So if we rearrange that, what does cosine squared minus 1 equal? Careful, negative sine squared. Again, you don't memorize every possible iteration of this thing. You know the first one, and then you move things around as needed. So cosine squared minus 1 would be negative sine squared. So negative sine squared over cosine of x plus 1. So one of the signs will cancel. And then we substitute again. So sine of 0 is 0. Cosine of 0 is 1. 1 plus 1 is 2. Is this an okay answer? Is it okay to get 0 on the top? Yeah, so our answer is just 0. I think part D, we don't have time to do it, but I think part D doesn't work. I mean, you do the same steps, but you end up with 0 in the bottom. And so that one eventually, 5 minutes later is going to be infinity. And you can see that E and F have, I think, obvious conjugates to try. So here's the techniques. Roman numeral 1, always try substitution. If it doesn't work, then you've got options for the second thing to do to clean it up. And the good news is, it's usually pretty easy to tell which one of the options to use. Right? If it's a complicated fraction, then fix the fraction. If there's a square root, then do a conjugate. If it's a polynomial, then factor and reduce. So usually students don't have a problem like picking which method to use. It's just the algebra technique within the method that lets them down. So today is definitely a day where it's not calculus that's a problem, it's the algebra. A good reminder that calculus is easy, algebra is hard. All right, today's assignment is worksheet number 2. And again, try substitution first, because some of them will work with just substituting. So don't jump to fancy techniques until you try substitution first.